Hello class, this is lesson 4-6 about piecewise and step functions. So to begin, let's discuss a piecewise function. It's a graph that has two or more pieces that are graphed separately. So here I have the function f of x that is equal to 2x plus 4 if the x values are less than or equal to 1. But then it's also equal to negative x plus 3 if the x values are greater than 1. So we're going to graph those, and then we are going to state the domain and the range. To begin, I'm going to pick numbers that are less than or equal to 1, and I'm going to plug it into 2x plus 4. So 2 times 1 is 2, plus 4 is 6. 2 times 0 plus 4 is 4. 2 times negative 1 plus 4 is 2. 2 times negative 2 plus 4 is 0. And 2 times negative 3 plus 4 is negative 2. So now I can go ahead and plot all 5 of those points to help me form what my graph is looking like. And since I'm graphing all the x values that are less than or equal to negative 1, it is starting at 1, 6 and going in the opposite direction. Now I'm going to go ahead and pick numbers that are greater than 1 and plug it into negative x plus 3. So negative 1 plus 3 is 2, negative 2 plus 3 is 1, negative 3 plus 3 is 0, negative 4 plus 3 is negative 1, and negative 5 plus 3 is negative 2. So I can go ahead and plot those, except because it could not equal 1, that means that this point is going to be an open circle on my graph. So 1 up 2 is an open circle. And then the rest are all regular dots. And I'm going to go ahead and draw my line starting at the circle and going in the opposite direction. So this here is a piecewise function. If I'm going to describe the domain, I can say that it is all real numbers. I could pick any number that I wanted for the x value. But for the range, there is a limit. The highest y value is at 6, so I would say all the y values that are less than or equal to 6. Let's go ahead and graph another piecewise function when f of x is equal to negative x plus 1 if x is less than or equal to negative 2, and negative 3x minus 2 if x is greater than negative 2. Then we will state the domain and the range. So let's start by picking x values that are less than or equal to negative 2. And then we're going to plug it into negative x plus 1. So negative 2 plus 1 is 3. Negative 3 plus 1 is 4. Negative 4 plus 1 is 5. And negative 5 plus 1 is 6. So now we can plot those 4 points, and since we are starting at negative 2, 3, our line is going to go to the left through those points. So now we can go ahead and find the second piece of our function when the x values are greater than negative 2. So negative 3 times negative 2 is 6, minus 2 is 4. Negative 3 times negative 1 is 3, minus 2 is 1. Negative 3 times 0 is 0, minus 2 is negative 2. And negative 3 times 1 is negative 3, minus 2 is negative 5. So now I have 4 more points, but again, my first point is going to be an open circle at negative 2, 4. So I'm going to draw my open circle there and then plot my other 3 points to give me the direction of the rest of the graph, and I'm going to draw a line that's going downward forever, starting at that open circle. So here, the domain, or the x values, would be all real numbers. I can pick any x value. But also, as you can tell, there's no limit on the y values, so the range is all real numbers as well. Now let's move on to a step function. A step function is a little different than a piecewise function. This is where the graph is going to have a series of horizontal line segments. So really, visually, it's going to look like a bunch of steps. And the greatest integer function is kind of like the parent function, where it says f of x is equal to this double bracket around the x. And this is telling us that the function is going to be the greatest integer less than or equal to the x value that you choose. And so I'm going to just draw it for you right here. And as you can tell, it looks like this series of steps where it is starting at one point and then it's leading off to a circle on the right-hand side. So let me go ahead and show you an example. We're going to graph the function with the double brackets of x plus 1. And then we're going to state the domain and the range. So I can choose any values for x, and I'm going to plug it in to find x plus 1, and then I'm going to write down the greatest integer that is less than or equal to the x value I chose. So let's go ahead and just pick some values for x. Let's start with -2. -2 plus 1 is -1. And then for my right-hand column, the greatest integer that is less than or equal to -1 is still -1. Let's go ahead and pick another value for x. And since I could pick anything, I'm going to pick -1.5. When I add 1, I get -0.5, and the greatest integer less than or equal to that is -1. Again, I could pick anything. I'll pick -1.25, which added to 1 is -0.25. And again, the greatest integer less than or equal to that is -1. Now I'm going to pick just -1. When I add that to 1, I get 0. And that, again, is still equal to 0. So I'm going to put that down. And then I'm going to pick maybe -0.25. And when I add 1, I get positive 0.75. But the closest integer that's less than or equal to that is still 0. I'm going to pick 0. 0 plus 1 is 1. And the greatest integer equal to that is still 1. I could pick 0.5 plus 1 is 1.5, but the closest integer that's less than or equal to that is 1. When I pick 1, 1 plus 1 is 2, and that still is the same. And then I'm just going to pick one more, 1.75. And when I add that to 1, I get 2.75. And the closest integer that's less than or equal to that is 2. So now I want you guys to notice the breakdown of how some of these x values are giving me the same value in the function. For instance, any of those x values are giving me the y value of -1, of 0, of 1, and then of positive 2 as well, and so on. So I'm going to go ahead and plot these for you, like -2 down to -1 is my first point, -1.5 down to -1, -1.25 down to -1, -1, comma 0, -0.25 at 0, 0 up to 1, 1/2 up to 1, 1 up to 2, and 1.75 up to 2 as well. And since there were a variety of points I could have chosen, I can just draw my straight line segment ending with an open circle, and then I can continue this pattern going all the way up, but then also continue the pattern going backwards and downwards. And this would give me my step function. Okay, so now to describe the domain and the range, again, for the domain, like I did, I could pick any x value. So this is all real numbers. But for the range or the y values, I'm only including integers. So I would say all integers. Let's do one more example. This time we're going to graph the step function of x minus 2. Okay, and then we're going to state the domain and the range. So like I did before, I can pick any values for x. This time I'm just going to start with maybe -1. So -1 minus 2 is -3. And the greatest integer less than or equal to that is -3. And like before, I can just pick some random values like -0.5. When I subtract 2, that's -2.5. But the greatest integer that's less than or equal to that is -3. My next value I'm going to pick is 0. 0 minus 2 is -2, which again is -2. I could also pick maybe 0.25. When I subtract 2, that's -1.75, but the closest integer less than or equal to that is still -2. When I plug in 1, 1 minus 2 is -1 across the board. 1.75 minus 2 is -0.25, and the closest integer that's less than or equal to that is -1. After that, I'm going to pick 2, and 2 minus 2 I know is 0, which is also equal to 0. And then I can pick maybe 2.5. When I subtract 2, I get 0.5, and the closest integer that's less than or equal to that is 0. And so now that I have some different values chosen, I can see some similarity between them. So I'm going to start at -1 down to -3, and I'm going to draw my step ending with an open circle. Same with 0 at -2, 1 at -1, 2 at 0, and so on, going in the positive direction, but then also going backwards in the negative direction. And for this final problem, the domain I can see is all real numbers. And similar to before, the range is only going to be integers. So I can say all integers. And that's it. So I hope that this lesson made sense. Please let me know if you have any questions when you come into class.